Okay, we want to try to create something that is in some sense the opposite of taking a square. So for example, what does it mean if I say a is equal to b squared? Well, that means that a is equal to b times b. So what we want to do is we want to introduce something called the square root, where we will say that a is equal to, this symbol here is going to be called the radical b, if, so that's if, this is if, a times a equals b. So, square means a equals b times b, but if we take the root of b, that means a times a is equal to b. So we're looking for some number so that when we square it, we get b. However, there are going to be some issues. Let's think about this for a moment. For example, let's start with the square root of 4, which most of you are probably already thinking 2. And this is correct. Radical 4 is 2. However, going just from this definition, there are actually two numbers that are going to work. You see, we know that a is equal to the square root of 4 if a times a equals 4. And if a is 2, well, we do have 2 times 2 equals 4, but we also have negative 2 times negative 2 equals 4. As a matter of fact, whenever a times a is equal to b, we will have negative a times negative a equals b, because these two negatives will cancel each other out. So we want to deal with that. So how are we going to deal with that? Well, what we're going to do is we're going to be more careful when we define this radical symbol. So we say that a is equal to the square root of b if a times a is b and a is greater than or equal to 0. So we're going to call this actually the principal square root. And whenever we use this radical symbol, we're going to only want the positive. Now, let's do some examples. For example, if we want a to be square root of 9, we're looking at numbers so that a times a equals 9. Well, the choices are going to be a equals 3 and a equals minus 3, but we want the principal root because that's what this radical symbol wants or is asking for. So what we're going to get is a equals 3. Now, if for some reason you didn't see right off the bat that a is equal to 3 from a times a equals 9, that's fine. We know how to solve a squared equals 9. Simply rewrite it as a squared minus 9 equals 0. This is going to seem like ridiculous overkill to many of you, but I'm going to do it anyway just to show that if we know our difference of squares rule, we get the following. And then we know a is equal to 3 or a is equal to negative 3 because either a minus 3 is 0 or a plus 3 is 0. So, one more example. Let's try to find the square root or the radical of 0. So the principal square root of 0. Now, we want a times a to be 0. We know that one of these two numbers must be 0 because that's the only way a product can be 0. So we get either a is 0 or a is 0. Now, notice that we didn't have to throw anything out. Both roots ended up being sort of 0 here, right? If a is 0, a is 0, and if a is 0, a is 0. And that's fine. Remember, our definition said that a is radical b if a times a equals b and a is greater than or equal to 0. So why did we only get one root? Well, we did get 0 and negative 0 in a sense But negative 0 is the same as 0, so that's why we only got 1. Looking at one last example, if we want the square root of negative 4, what would we want? Well, we would want some number so that a times a is negative 4. But at least for our real numbers, anything squared is going to be positive. Because if a is negative, or it's at least going to be non-negative. If a is negative, well, a times a is going to be positive because it's a product of two negatives. If a is positive, we're going to get a positive number. And if a is 0, we're going to get 0. So there's no way I can get negative 4 here. So this is going to have no solution in the real numbers. So, what have we seen? We've seen that we have this symbol. We've defined it to be the principal square root, or the radical, which means we're going to take the root that is greater than or equal to 0. And we've seen that we can have actually one solution or 0 solutions when hunting for this principal square root. In general, however, if all we want are roots, we are always going to have 2 square roots for any positive number, 1 square root for 0, and no square roots for the negatives. We'll look at some more examples in the upcoming video.